Let's start the class. See, last class we discussed about theorems. Two theorems we have discussed. The most important theorems we have discussed. The first theorem we have discussed was about circles. So in that part, arc, segment, sector, everything we have discussed. Now what we need to discuss is about congruency. So if two circles are of equal radius, if two circles are of equal radius, they are considered to be congruent. That's a very important thing. So like if two circles are of equal radius, so how we are going to understand that? If two circles radius is same, so that means the radius is exactly coming as this one as 5 and this one is also as 5. So 100% these two circle radius is same, so they are considered as congruent. The next important point, like if somebody will ask that if two radius exactly, if two arc of a circle, if two arc of a circle are congruent, then corresponding chords are equal. That is also very very important, that if two arc of a circle are equal, like if I'm going to say that this is chord and this is chord. So now if these two arc of a circle are equal, AB and CD, these are the two arc of a circle, and if these two arc of a circle are equal, then their chords are equal. So definitely the chords are exactly AB will be equal to CD. This is exactly one of the most important part. So if two arc of a circle are equal, their chords are also equal. So that's the another important theorem we are going to understand. Now the next important point to be noted as about the theorem. So we are going to go about the theorem and we are going to talk about the next theorem. The next theorem is if two chords of a circle are equal, then their corresponding arcs are congruent. That is also very, very important. So that's again we are going to understand. Like if two chords of a circle are equal, like it is already given that this is AB is the chord and CD is the chord. So if these two chords of a circle are equal, if these two chords of a circle are equal, and what we have to do here is their corresponding arcs. The corresponding arcs like minor, major, they will be congruent. So if this chord length is equal, this length and this length is equal, then definitely it will be congruent. This is again a very important section. So this chord is equal to this chord, then that means this length will be equal to this length and this length will be equal to this length. So this is the most important thing about congruency of circle. Now the most important theorem of circle. The circle is having a very important theorem. The most important theorem of circle is that the perpendicular from the center of a circle to the chord bisects the chord. This is the most important theorem. The perpendicular from the center of the circle to the chord. The theorem is first theorem. The perpendicular from the center of the circle, from the center of the circle to the chord, from the center of the circle to the chord, bisects the chord. The perpendicular from the center of the circle to the chord bisects the chord. This is one of the most important theorem, and you must remember this is NCERT theorem. So writing the theorem and doing this theorem is very, very important. The perpendicular from the center of the circle to the chord bisects the chord. So how to prove this one? First you need to write the given section. For proving these type of questions, writing sections, given sections are very, very important. So how we are going to write it? First we are going to draw the circle. So once you are drawing the circle, just check this one out. First you are going to draw the circle. So draw the circle first. So this is exactly the circle given to you. Once you are drawing the circle, now after drawing the circle, you have to identify the center. The center of the circle is O, and then we are going to draw the chord, because in this question what they are telling that the perpendicular from the center of the circle to the chord bisects the chord. The perpendicular from the center of the circle to the chord bisects the chord. So from the center of the circle to the chord we are going to draw the perpendicular from the center of the circle to the chord. So this is actually perpendicular drawn. Okay, so the perpendicular from the center of the circle to the chord. So here AB is the chord, and we have drawn one perpendicular. The perpendicular is drawn, the perpendicular from the center of the circle to the chord bisects the chord. That means we have to prove, if we will put D, so our proof should be AD is equal to DB. This is the most important thing. So our proof has to be AD is equal to DB. This is what we need to prove. For proving that, we are going to write given section. So what is given, we are going to write. There is a format of writing the given section. First, we are going to meet this two. So in this section, what we need to do is, if we will prove that this section is congruent to this section, half of our work is over. So the perpendicular from the center of the circle to the chord. So first in the given section, we will write a circle C with center O and radius. A circle C with center O and radius R is given. Another thing, what is given? Another important point, what is given here is a circle C with center O and radius R is given. After that, the second important information, what they have given here is like key OD is perpendicular to AB. OD is perpendicular to AB. This is also given. And OA and OB are radii of a circle. So OA and OB are radii of a circle. This is actually given. So now what we need to prove that? To prove that AD is equal to DB. This is what we need to prove. We need to prove that AD is equal to DB. This is what should be the proof. To prove that AD is equal to dB. This is the proof. To prove that AD is equal to dB. So once we have to prove, so how we are going to prove this one? So in the proof section, it is very, very simple to do it. Why? Because we are going to take these two triangles. We are going to take this triangle. We are going to write O. We are going to write D here. We are going to write here A. And we are going to write here B. So we have taken this one out. Now this is perpendicular, means 90-degree given. Now OA and OB are radii and OD is common. That's it, proved. So now we will write in triangle ADO and triangle ADO and BDO. So in triangle ADO and triangle BDO, what is given to you? It is exactly given that angle A, because OD is perpendicular to AB, since OD is perpendicular to AB, so since here what is given to you is OD is perpendicular to AB, OD is perpendicular to AB, so what we can write here is that angle ADO is equal to angle BDO, 90 degree. So this is exactly given section. Already it is given. Now what is common? OD is equal to OD. Because in both the triangles, OD is common. So we can say OD is equal to OD. That is coming as common. Now the last section what we need to show is the last part what it is there is this OA is equal to OB. OA is equal to OB and they are what? They are radii of a circle. So since they are radii of a circle, this section is done. So 100% what we are going to assume here is these two triangles are going to be congruent, because the most important thing here is how these two triangles are getting congruent. This side equal to this side, this is coming 90 degree and this part is common. So definitely right hypotenuse side, right hypotenuse. So when RHS we need to prove one angle, we need to prove 90 degree. Understood? Second part is hypotenuse should be equal. So here this is the hypotenuse. So for this two side, this is the hypotenuse, and since this hypotenuse side is serving as radius, it is also equal, and OD is equal to OD is the common part. So since OD is equal to OD is the common part, comes in Wang. This side, Ama. Near. So look here. So OA is equal to OB radii. Come here. I'm going to prove this part. A very important theorem I'm proving here. Sir, be regular and in time. Okay. So now look here, beta. So we have exactly done two things. We have exactly done two things. Equal, then cos. See, so here one very important thing that is given to you is the most important part what is given. This theorem is one of the most important theorem. In this theorem, what you have to prove is कि when you are drawing a chord, so this is chord, okay? So this is the chord of a circle, and when you are drawing a chord of a circle, this is creating lots of problem. So this is exactly the chord of a circle. So what is AD? This is the chord of a circle. Okay, beta. So when you are taking the chord of a circle, like this is the center and this is the chord. Okay. Now in this one, this is AB is the chord of a circle. Now you drew one line perpendicular. This is what, beta? This is the perpendicular line. So when you are drawing a perpendicular line OD, done na? So when you are drawing a perpendicular line OD, they are telling that the perpendicular from the center of the circle, the perpendicular from the center of the circle to the chord, understood, is bisecting the chord. So what you have to prove here is AD is equal to DB. What you have to prove? AD is equal to DB. So this is something what we need to prove. So first note down the perpendicular from the center of the circle to the chord bisects the chord. The perpendicular from the center of the circle to the chord bisects the chord. The perpendicular from the center of the circle to the chord bisects the chord, and this is one of the most important part. The perpendicular from the center of the circle to the chord bisects the chord. So we are drawing a perpendicular and it is exactly going to bisect the chord. So note down this one. This is most important. This is one of the most important theorem. Got it? For circle. Hey, monkey. Science also same notebook. Maths also same notebook. Keep separate. Okay. Don't mix things. It's not good. So now come on, come on, come on, do it. Note down that part. The center, the perpendicular drawn from the center of the circle to the chord bisects the chord. Okay? Done? I hope you have understood written. So what we have to prove? We have to prove that this side length is equal to this side length. This is what we need to prove. So what work we are going to do? We will be taking first the given section written, that is a circle is there with center O and radius R. The technique of writing is like that. And now what is given? According to the question, they have given OD is perpendicular to AB. OD is perpendicular to AB. And we know that whenever any line is perpendicular means it will make what degree? Anjali, good. Yes, we will go next question. Just we'll finish this one, Anjali. So here, this will come 90 degree. So a circle with center O and radius R is given. So OD is perpendicular to AB. OD is perpendicular to AB. Now OA and OB are radii. What OA and OB are? Radii. Now what we need to prove? AD is equal to DB. This is what we need to prove it up. That is AD part is equal to DB part. AD part is equal to DB part. So what we are doing here is we are taking these two triangles. What are the two triangles taken? This part and this part. That is ODAB taken. So this is already 90 degree. Done. So this is already 90 degree. So we have written this one. So now OD is equal to OD. OD is equal to OD common. Sam, what is common for both the triangle? What is common? OD. And here, what is the angle? 90 degree. And this are radii. So OA is equal to OB are radii. So once you wrote this, two triangle will become congruent. That is triangle ODA is congruent to triangle ODB. By what criteria? Right hypotenuse side. By what criteria? Right hypotenuse side. So once you have written this two triangle congruent by right hypotenuse side, next by CPCT, AD is equal to DB. Note down. AD is equal to DB by CPCT, it will become equal. That is congruent part of, sorry, corresponding part of congruent triangle. What it will become, beta? Corresponding part of congruent triangle. Come on, go for it. Note down. We'll go for the next question. This is again a type of theorem. Understood? So this theorem is the reverse theorem. If somebody will ask you, this theorem is going to be the reverse theorem. Let's check this one out. Come on, we can do it, please. So question is, the line joining the center of the circle, the line joining, what it is written as, the line joining the center, the line joining the center, the line joining the center of a circle to the midpoint of a chord. The line joining the center of a circle to the midpoint of the chord. Which part? Midpoint of the chord. Midpoint of the chord to the midpoint of the chord, the line joining the center of the circle to the midpoint of the chord. What is the speciality of midpoint? Midpoint divides a line into two equal halves. So only it is called as middle point or midpoint. Or it is called as middle point or midpoint. So here a line joining, the line joining the center of the circle to the midpoint of the chord is perpendicular to the chord. Midpoint of the chord is perpendicular to the chord. Is perpendicular is perpendicular to the chord. Is perpendicular to the chord. Now we have to prove it. Same format, same circle, same everything, but solving part will be little different. Let's check this one out. So first we will draw a circle. Circle done. Okay. So now what next we are going to do? See, in this circle, first we are going to draw a line from the center of the circle. So let's take the line from the center of the circle. So this is the center of the circle. This is O, and we are going to draw a chord. Okay, we are going to draw a chord. So let's this be the chord. Now a line drawn from the center of the circle to the chord. Line drawn. Okay. So after that, we are going to take this radius. So this and this will become the radii. Done. Till here it is okay. So now it is O, A, B, D. Done. So we are going to draw this first. Now what we are going to write? What is given? What is given to you? A circle C with center O and radius R is given. Understood? After that, what is the next point? What is given to you? The next point is a line is joining from the center of the circle to the midpoint of the chord. A line OD is drawn from the center O to the midpoint of the chord D. To the midpoint of the chord D. From the center to the midpoint of the chord D. So that means from where to where we have drawn? We have drawn from the center to the midpoint. From the center to the midpoint. So what is the meaning of, since D is the midpoint? Since D is the middle point or midpoint, so you know that midpoint divides the side into two equal halves. So AD will be equal to DB. So AD will be equal to DB. Done? So since it is a midpoint, AD will be equal to DB. Understood? So now what next we are going to do? We need to prove it is perpendicular. Na? What we need to prove? It is perpendicular. So we'll go reverse. Okay. This much is given section. Got it? Now to prove that angle ODA is equal to angle ODB. This is equal to 90 degree. This is what we need to prove. Angle ODA is equal to angle ODB is equal to what? 90 degree. And this is what you need to prove. Angle ODA is equal to angle ODB is equal to what? 90 degree. To prove this section, what we are going to do? We will start the proof section. Which two triangles we are going to take? Very good. So in triangle ODA and triangle ODB. So how we are going to proceed? First, OA is equal to OB. OA is equal to OB. Why? Because they are radii of circle. Second, what is common? Super. OD is equal to OD is common. And next, what is the point beta given? AD is equal to DB, that is given. All this given section has indicated AD is equal to DB. This bisector, midpoint, everything, it is given. So, from this conclusion, what we are going to say? That means we are going to say triangle ODA is congruent to triangle ODB. By which criteria, beta? Side, side, side. It is not RHS. It is side, side, side. Why? Because this side is equal to this side. And this side is equal to this side. Because they told now that this is the middle point. Middle point will divide the chord into two equal halves. So middle point is dividing the chord into how many equal halves? Two equal halves. So here AD is equal to DB. AD is coming equal to what? DB. So that means SSS, these two are exactly congruent. That means what we can say, this angle, our basic criteria was this angle is equal to this angle. So what we will say, angle ODA is equal to angle ODB by CP CT. But this is not the end now. So because we know that AB is what? Line. What is AB? AB is a line. And now this angle is equal to this angle. So we need to prove this part now. AB is a line. Now since AB is a line, we will write. Now since we will take this as equation 1. Okay. So what we are going to write? Since AB is a line. Understood? Huh? Now angle ADO plus angle BDO will be equal to 180 degree. What pair? Linear pair or straight line. That is, the sum of adjacent angles should be AB is the chord. Yes, Anjali, we can say that AB is a chord also. Understood? So there we can actually say that AB is a chord, or we can say that AB is a chord, Anjali, but one thing is that AD is equal to DB. Understood? AD is equal to DB. AB is a chord, and we can say that I hope you might have understood this one. Now, beta, already we have proved ODA is equal to ODB. This angle is equal to this angle. So, what we will write? 2 times of angle ADO is equal to 180 degree. Why, beta? Because since using equation 1, using which equation? Using equation 1. Are you understanding how to proceed with geometry? So beta, angle ADO will be equal to 180 degree minus 2. It is coming as 90 degree. Therefore, angle ADO equal to angle BDO is equal to 90 degree. Hence, OD is perpendicular to AB. This is what only they asked. So OD is perpendicular to AB. This is what they asked and we have proved that one only. OD is perpendicular to AB. Come on, go for it. Note down. First I did one thing. I wrote here to here. So this part I wrote. After that I went here. Snakes and ladder. Okay. After writing till here, I went here. Okay. Note down. Did you finished? Did you draw? No drawing. Oh, that drawing is done? Very good. So you need to draw that one and then you need to identify and then you need to write that. That is the two very important theorem. This is the most important theorem. Now another one very important theorem is given to you, that is NCRT theorem. So all these three theorems are from which axis? NCRT. So all these theorems must be known. Where is Kanishk? I think he is not knowing the timing. Kanishk is not knowing the timing. Fine. Huh? Yeah, right now it is 5:16. I started today 4:40 now because Trikul I have to go little early, so I put this timing. Now, but this is done now. You understood this part? Any doubt is there? Everything clear now? Okay, you can teach Kanishk in my absence. First part, what I have given, perpendicular. And what we proved, this side is equal to this side by simplicity. And second part, what we did, we proved this equal to this and we proved this is 90 degree. So that's the two major thing we have done. I hope you might have understood this one. So we'll go for the next one. Are you ready for it? Shall we start? Question is, write down. Write the question, another theorem. This is a very important theorem. Prove that the perpendicular bisector of two chords, prove that the perpendicular bisector of two chords, prove that the perpendicular bisector prove that the perpendicular bisector means beta which bisect it perpendicularly. Okay, prove that the perpendicular bisector of two chords, write down, prove that the perpendicular bisector of two chords of a circle monkey. How much late you did, Ray? See, my monkey is joining so late. Good evening, auntie. Auntie is very angry on you. Where were you? Hmm? Write down. Prove that the perpendicular bisector of two chords of a circle. Prove that the two theorems you have missed, monkey. The two theorems you are going to write. Okay. Now we are doing the corollary section. This is a very important part. Remember this one. So now write down better. Prove that the perpendicular bisector of two chords of a circle. Two chords of a circle intersect at its center. Two chords of a circle intersect at its center. Intersect at its center. First note down this one. So happy, I came late, auntie. Draw this beta first. Okay. This is, now what we are going to do, we will be drawing a center, but we don't know this is perpendicular. First we will draw one perpendicular, shortest distance. Okay, we'll try to draw another perpendicular. We are going to another, we will draw and try to assume. Got it? So note down first, draw this one out. Everything, this is very, very important. Please kindly do this one. So beta, this one will become P and this one will become Q and this one is considered as L and here it is R and here it is S. This is center O and this is O dash. Come on, go for it. First draw this one out. Okay, first draw this part out. Done? Oh, you went to hospital, then no problem. Okay, come on, come on, come on, note down. So first write given, what and all things are given. Okay, so write in the given section, write everything. This is one of the most important question and many times in school they are asking this question. So this question is one of the most important question for you. Write down beta, PQ and RS, PQ and RS are two chords of a circle, are two chords of a circle. Understood? How many chords of a circle are given beta? PQ and RS are two chords of a circle. Now this circle is having what beta? Center O and radius R. Got it? And their midpoint and their midpoints L and M. Which one we have taken midpoints beta? Midpoints we have taken as L and M. And their midpoints and their midpoints L and M and their midpoints L and M respectively. What is that midpoints are beta? L and M are the midpoints respectively. Understood? This is note down very nicely. So these are the midpoints. L and M are what beta? Midpoints respectively written. Now we are going to prove in a different way, hypothetical way. Usually O is the center na beta and this one supposed to be perpendicular. But now what we are doing, we are hypothetically telling that okay, O is not the center. Let O dash be the center. O dash be the center. If O dash will become the center, then this part will become perpendicular and this part will become perpendicular. So that we need to understand. So let's write it in a very different way. What we will write? Suppose. Now here we are going to write suppose perpendicular bisector, suppose perpendicular bisector, suppose perpendicular bisectors O dash L and O dash M of PQ and RS, of PQ and RS respectively meet at O dash. respectively meet at O dash. So where it is meeting? O dash. Where they are meeting beta? O dash. Okay. Now we need to prove that O dash coincides O dash is coinciding with O. This is one of the major section. O dash is coinciding with O. So this is one of the most important part where O dash is exactly going to coincide with O. You please remember this section. So we need to prove that O dash is coinciding with O. Okay. So now let's check this one out. To prove that O dash coincides with O. This is one thing we need to understand. O dash is coinciding with O. Now first construction we already did construction now. So we have to join just OL and OM. In construction section we will write construction. This is a very important question. Please do everything I am writing. Joining, dotted line means joining OL and OM. Dotted line means beta joining OL and OM. Okay, when is the PT to January? We'll be checking, beta. We'll be checking, but you should be prepared now. See, my target is before the November. What you call? November finish. We need to finish the syllabus. If syllabus is finished, means we'll be free. After that, we will be finishing revision, MCQs and everything. Because ninth part is very important for 10th, so it is 100% important for you to prepare it. That's the most important thing you must remember. Okay. See, from our side, we have to be prepared. When they will be taking test, it's of their use. Bah, very good. Surprise. Congratulations. Your exam is on January. So till December, you don't eat. Okay. Hmm. Now we take construction. But all exams. So what we are going to do? We will be joining OL and OM. So what we have joined? OL and OM. So till here it is done. Now we are going to start the proof section. Till here written now? Very nice. I'm seeing you are writing everything. Super beta. Hey. So now write proof section beta. In proof section, what and all we need to do? In proof section, right? In proof section, right? Ki joining, since you have joined, so since L is the midpoint beta, since L is the midpoint, what is the midpoint? L is the midpoint. You need to understand one thing. We need to prove that O dash and O coincides. O dash and O coincides because we don't have any other way to find that proof now. We can draw the line and we can do the construction and prove it. But here hypothetical part is, see, prove that the perpendicular bisector of two chords. So this, which is the perpendicular bisector. So OL can be the perpendicular bisector and OM can be the perpendicular bisector. So OL, the perpendicular bisector of two chords of a circle intersect at its center. So definitely here center part is the most important. Center part is the most important. So here what we are going to do, our strategy wise, what we are going to do here is we will be taking two centers and finally we will coincide one center with the other center. I hope you might have understood. Arunisha, game time over. But so now look here. So that means, auntie, is this question NCRT? Yes, Amma. This question is NCRT only. So only doing this question. In absence of this question, you won't be able to understand anything. So the most important part here is you need to identify and write down. So that is what the most important section here is. You need to say that whatever perpendicular bisector is exactly drawn from the two chords of a circle, they have a common center. So that common center only, they have a common center only, and that common center only we are finding. What is that reaction here? So now look here. So prove, since L is the midpoint, note down. Since L is the midpoint of chord PQ, monkey, focus. Since L is the midpoint of chord PQ, so what we will write? OL is perpendicular to, therefore we can write, therefore OL is perpendicular to PQ. Done? So OL is perpendicular bisector of PQ. It is also given OL is perpendicular bisector of PQ. Come on, no problem. So look here, I was just kidding you here. So now look here, OL is perpendicular. So since OL is perpendicular to PQ and they told that perpendicular bisector. What is the meaning of bisector? The meaning of word bisector means it bisects the side into two equal halves. So if I am drawing any perpendicular bisector, so it will be 90-degree also and it will bisect the side into two equal halves. If I am saying only perpendicular is different. Perpendicular bisector means it will be drawn perpendicular also and it will divide the side into two equal halves. That's the basic difference between perpendicular and perpendicular bisector. Arrow, focus in work. So that's the difference between perpendicular and perpendicular bisector. Understood? So this is exactly what? This is perpendicular bisector. So since it is perpendicular bisector, if OL is perpendicular to PQ, that means OL will divide PQ into two equal halves also. So that's what the point we are going to write. So OL is the perpendicular bisector of PQ. So what we will write? OL is the perpendicular bisector of PQ. So beta OL becomes what? OL becomes the perpendicular bisector of PQ. So now OL is there, O dash L is also there, na? O dash L. They become the perpendicular. If one is perpendicular bisector means another one will automatically become the perpendicular bisector. So if OL is perpendicular bisector, that means O dash, yes beta. So if OL is perpendicular bisector means O dash L will also become perpendicular bisector because both are serving the same purpose, na? Good morning, sir. Good afternoon, sir. And now last is good evening. This was the most important theorems I have taught and you are going to read it again. Okay. So this is the most important theorem, Kanishk, I am doing right now, beta. You are so late today. Why? Okay, no problem. So whatever I have taught now, today what work you are having is after class, he is going to teach you. Today your teacher is him only. Okay, so OL is perpendicular. Beta, OL is the perpendicular bisector of PQ. So if OL is the perpendicular bisector of PQ, that means OL as well as O dash L is perpendicular bisector of PQ. Perpendicular bisector of PQ. So now what next we are going to do? Both are exactly going to be the perpendicular bisector of PQ. So is this possible? Is this possible? No. So what we are going to write? O dash L lies along OL. No, it is not possible. Now, how can 2 points will be serving the same basis? So similarly, M is the midpoint. We will take this as 1. Now say similarly, M is the midpoint. Similarly, we can solve for the other side also. So similarly, we will write similarly. M is the midpoint. RS. So M is the midpoint of what? RS. So that means OM is perpendicular to RS. That means OM is perpendicular bisector of RS. OM is perpendicular bisector of RS. What is OM beta? Perpendicular bisector of RS. So OM as well as, so finally what conclusion? Therefore OM as well as O dash M are perpendicular bisector of RS. Are perpendicular bisector of RS. So both are perpendicular bisector of RS. That means O dash M lies, where O dash M will lie beta? Very good. O dash M lies along OM. Done. This is equation 2. So with these two equations, we fall into a conclusion. And what is the conclusion, beta? That means O dash and O are not two different points. They are same point. So from equation 1 and equation 2, from, yes beta, from equation 1 and equation 2, we can conclude that O and O dash are not two different points. Understood. So O dash and O are not two different points. They are considered as the same point. O dash and O are not two different points. They will be considered as what? Same point. So it will become easy for us to prove. So they will be considered as same point. O dash and O are not two different points. They will be considered as same point. O dash and O are not two different points. They will be considered as same point. I hope you might have understood. O dash and O are not two different points. They will be exactly same point. Remember this one. That means O coincides with O dash coincides with O. What is the final conclusion? O dash coincides with O. So they are not two different points. They are exactly the same point. Note down, this is one of the most important part of a theorem where perpendicular bisector part is creating problem. You need to understand most of the theorems. I really wish you people to do it very nicely. NCERT book is there, Kanesh? Give me beta. Because circle 2 exercises are there, na? Okay. I think 3 exercises are there. We are going to prove another proof. Pradish Prasid Prasid auntie. Prasid means, what is the meaning of Prasid Mata? ये बताएं आप. Prasid means what? Proceed or Prasid? That you need to say me. Proceed or Prasid? Monkey. Now look at it. Now we are going to go to the next theorem. Equal chords of a circle subtend equal angle at the center. That's one theorem. Equal chords of a circle subtend equal chords of a circle are equidistant from the center. Come on, write down this. Equal chords of a circle means noted. That was in Tamil, Hindi, English, which one? So write down equal chords of a circle. Write down equal chords, equal chords, Hindi. Equal chords of a circle, equal chords of a circle, equal chords of a circle are equidistant from the center. Are equidistant from the center. Equal chords of a circle are equidistant from the center. This is exactly what you need to prove. Equal chords of a circle are equidistant from the center. Equal chords of a circle are equidistant from the center. This is what we need to prove. Okay. So now equal chords. First we are going to draw two equal chords. Re Kanishk, look here, beta. First we will draw circle. Okay. Now two chords we will draw. Equal chords of a circle. So one and two chords we will draw. Okay. Equal chords of a circle are equidistant from the center. So one dotted line we are going to do, which will exactly going to symbolize the center here. So here center is there. Okay. So we will draw like this. Me. When the damage is built, means we can't do it anything. Understood? So again, huh? I can't do anything now. I have written equal chords of a circle are equidistant from the center. No problem. I am having another way also. I will draw like this. Not possible. So you wrote this question now, equal chords of a circle are equidistant from the center. So we will play like this. What is the problem? This is the circle. Again, one more time we will draw. So these are two chords, one chord and another chord. And then from the center we will draw like this. That's it. No other thing. Okay. So now what we will do, we will take one center here. Okay. Now equal chords of a circle are equidistant from the center. So we will draw one line like this and we will draw like one line like this. Looking similar. So we will draw two lines like this and then here it is 90° and here it is 90°. Because from the center of the circle to the chord, oh, I'll try to come. You need to send your address. Okay. So now look here. Done. So equal chords of a circle subtend equal angle at the center, beta. So equal chords of a circle subtend equal angle at the center. So this part will be written as A, B, C, D. We will write it as E and F. Understood? So what is given to you? The given section is the chords are equal. Given a circle is there. What is the circle, beta? A circle C with center O and radius R. Anjali, you need to say Jaisalmer, Rajasthan, and you want me to come there. You're serious? So a circle C with center O and radius R, AB and CD are chords of a circle. Okay, what is the question? Equal chords of a circle subtend equal angle at the center. So what we need to prove is this angle is equal to this angle. Correct, no? Oh, this is equidistance. Equidistance means we have to prove OE is equal to OF. This distance we have to make equal. So a circle, AB and CD are chords of a circle. So AB and CD are what, beta? Chords of a circle, and AB is equal to CD. Equal chords are given, na? So that part is exactly given to you. Now next part, what is exactly is there is, now we will start proving this section. Okay. So equidistance means we have to prove OE is equal to OF. That part we need to prove. So prove that OE is equal to OF. This is what we need to prove. OE is equal to OF. So this section we have to prove that OE is equal to OF. What next work we are going to do? Okay. First though we will say that in proof section, we will say that from the center of the circle, in circle C with center O and radius R, from the center of the circle, the line drawn, okay, we will write like this. The line drawn is perpendicular to the chord and is it about to rain? Kanish? Oh, it is perpendicular to the chord and bisects the chord. Okay. So this is exactly something we have to prove. So definitely that means what? OE is perpendicular to, therefore OE is perpendicular to AB and OF is perpendicular to CD. So we wrote like that okay fine, OE is perpendicular to AB and OF is perpendicular to CD. Now we know that if it is perpendicular and it will bisect it, means this half will be equal to this half, okay, and also we can say AE is equal to EB and DF equal to FC. So these two things done. Now what is our next work is? What is our next work is? Look here, our next work here is, so this much we have done. Now we are going to take one triangle, at least one triangle we can take. Let's take this triangle and take this triangle. Okay, now this is already 90 degree. Come on, this is also 90 degree. Now this side is equal to this side. Why? Because AB is equal to CD already given. So half of AB will also be equal to half of CD. Correct? Yes, absolutely. So what we are going to write, beta? In triangle OEA and triangle OFC. First, beta, OA is equal to OC. What they are? Radii. Understood? And beta OEA, angle OEA is equal to angle OFC. What is that? Equal to 90 degree. It is given already now. That is their perpendicular bisectors. What they are? Keys. In room, you say Rupa to give. Okay. So this is also given. So this is 90 degree and this is there. Now one more thing is there is, we know that AB is equal to CD. So half of AB will be equal to half of CD. Understood? So half of AB is AE is equal to CF. So this side also is done. Chords are equal given. Chords are equal. Chords are equal. This is also given. Now beta, that means the triangle is getting right side angle, sorry, side angle it is coming. It is coming as angle. We can take by vertically opposite angle also, this angle is equal to this angle, because here it is coming this side is equal to this side. Side angle is angle side is also not there. We need to prove angle side. So by vertically opposite angle, this angle, because this is exactly drawn, so this angle is equal to This angle also we can do. And also this side is there, this is 90 degree. So right hypotenuse side also we can take now. It is coming right hypotenuse, this is equal to this radii, so right hypotenuse side is better. So it will come triangle OEA is equal to triangle congruent to triangle OFC by right hypotenuse side. Then by CPCT beta, OE is equal to OF by which part? CPCT, corresponding part of congruent triangle. That's it. Corresponding part of congruent triangle. COY in triangle AOE and COF. COF, not Y. COF. It is looking like that, but it is F only. COF. Okay. No problem. So 1 hour of the class is over. Kanishk, note down beta this one. Rupanti is going to take care. Okay. I need laptop. But